These are AI agents I actually run. This one's name is Iggy. It lives in Slack and it answers questions about our docs, open GitHub issues. It posts updates in a Slack channel. We call it an intern at our org, and each department is slowly starting to build out their own. And these are my personal Hermes agents who grind through GitHub backlog. They organize my Notion. They answer and send emails, read YouTube statistics, and more. Now, as you can see, these agents are integrated with many different services. They make real authenticated calls to places like Notion, GitHub, Anthropic. And the catch is that none of them holds a single API key. Now, how is this possible? The keys actually live on a separate machine, and they get added to a request on the way out. Now, the tool that's doing that is something called Agent Vault. With Agent Vault, the agents hold nothing. Every key and all of the control stays on the broker. Let me show you exactly how this works. Now, first, quickly, why does this even need to exist? Traditional software is deterministic and predictable. For example, $50 would go in, a billing service would run, and a receipt would predictably come out on the other side. AI agents are not. They're built to act on whatever text they read, whether that's a web page, a file, a GitHub issue, and this is exactly what makes them exploitable. Now, if we have a few lines of malicious text in the wrong place, an AI agent can be talked into handing your credentials to an attacker. This isn't just hypothetical. I saw that SNCC ran a big security audit of the agent skills ecosystem, almost 4,000 skills from the marketplaces that these agents pull from, and they found that well over a third of them, over 1,400 skills, have at least one security flaw. Now, prompt injection and leaked secrets are one of the most common. Better than 1 in 8 had a critical issue, whether that was malware or code built specifically to exfiltrate your credentials. The point is, the plugins people install to make their agents more capable are in a huge number of cases quietly trying to steal their keys. So this is a real active problem space. Now again, traditionally we would have this deterministic software, but this breaks down when we have these non-deterministic AI agents. So we can't just give them the keys, and you can't fix this with a better secrets manager. Your secrets manager protects these credentials at rest and in transit to the app, but when we have these non-deterministic agents, this just doesn't suffice. So the fix can't be operational, it has to be architectural. Don't let the agent hold the secret in the first place. That is Agent Vault. It's an open source, cloud-agnostic credential broker, and it's a proxy that sits in between your agents and the APIs that they call. It holds the credentials on its own machine and then injects them into each request on its way out. The agent either holds a placeholder or nothing at all, and then the credential broker injects the real token or swaps it in on the wire. If you ever use man-in-the-middle proxy to inspect traffic, it's the same man-in-the-middle position, except instead of debugging requests here, we're injecting, or rather brokering, credentials. Whether that's SDK, CLI, MCP, it's all going to bottom out in HTTP, and so the broker can inject this credential no matter the interface. And that's the whole point of this video. The agents hold nothing. You keep every key and every rule in one place. And if you're putting agents into production, especially as a team, this is a pattern to standardize on. The agent gets the access, never the secret. If you want the deep why, the threat model, the full argument, I will leave our Credential Brokering 101 video in the description. This video is going to be specifically about Agent Vault. So let's check out how this is organized. We've got 3 fundamental components. First is going to be a vault. Our vault is a boundary. Generally, we're going to use 1 per project or 1 per team. The vault holds your credentials and your services that you allow, and then your agents are allowed to use them through the vault. Now, the credentials themselves are our real secrets. They are the actual key value pairs with our API keys, our tokens. They're encrypted at rest, and importantly, the agent will never read them. So there's no view in the product or on the wire that will hand these real values back to the agent. And then third, we have services, and a service is an allowed destination plus how to authenticate to it. So for example, GitHub here says allow calls to api.github.com and inject the GitHub token credential as a bearer token. Now this injection could be a bearer token, it could be an API key header, basic auth, or a placeholder it swaps into the path or the body. And if there's no service for a host, the broker will not broker for it. So this services list is an allow list. So we have our model, these 3 components, and notice that the agent is not holding any secrets here. So let me prove this with a real agent, Claude Code, and I'm going to start by showing you the problem that it actually solves. Okay, so I tell Claude to send this 1 credential demo token and to make a curl request to postmanecho.com/get. Now, Postman Echo is just a free endpoint that mirrors back and echoes whatever it receives. So if I run it as is, I have no broker in the path or anything like that. And this is what Postman Echo got, bearer demo token, our placeholder verbatim. So this dead string is everything that Claude has, so that's what goes out, and then that's what comes back. It can't unlock anything. Now let's set up Agent Vault locally. For this demo, Claude Code and Agent Vault are going to be running on the same local machine, so we'll see the credential brokering flow end to end. And installing Agent Vault is one command. We can grab it here in the docs. And when we install this CLI, it also installs its own certificate authority and trust, which is the way that it sees inside of HTTPS. And upon initial install, it's going to ask you to put your password. And once you see installed successfully, we can run agent vault server -d. And for this initial install, it's going to ask us for a master password. This will be used to encrypt the database with all of our secrets. I'm going to leave it passwordless just for this demo. And you'll put in the admin account email. Now, this first person to create an admin email and password will become our super admin. So now that our server is started, we can go to localhost 14321, and this will take us to our instance, and it's going to ask you to log in with that admin account. We'll create a new vault, and this vault is just for the demo. Credential store, I'm going to choose built-in. We'll create. Now I'm going to add a credential, and for the credential, I'm going to call this demo token. We'll give it a value, and we'll add it. And so in a real environment, this would be my real API key, right? It might be GitHub token with the GitHub token value. Next, I must add a service. So my service, I'm going to call Postman Echo. And this is me saying any call to postmanecho.com, inject this credential into the header with bearer auth, and we'll add service. Now, this local pattern is useful when you're trying to give access to a desktop agent like Claude Code, and you don't want to put real service keys in its configuration. Now, I do want to be clear that this local pattern doesn't provide any isolation because the agent and the broker are on the same box. Now, I can run the same exact Claude, except I wrap it in the Agent Vault CLI, where I run Agent Vault run. I point it at our demo vault that we created, and I'm going to give it the exact same prompt with the same placeholder, except this time it's going to route through the broker. So the same task, once again, I tell Claude, make a curl to postmanecho.com/get, which again is going to mirror back what postmanecho.com receives with authorization bearer demo token and show me the JSON we get back. Now note, this was the same task, but this is what Postman Echo got this time. Authorization bearer, this is the credential stored in Agent Vault. And we can see Claude says one thing worth flagging, the auth header in the echoed response shows this is the credential stored in Agent Vault, not the demo token I sent. The outbound proxy swapped the placeholder token for the real credential stored in Agent Vault on the wire. So if we go to our Agent Vault, I can click on my demo vault and I can show you that the credential that I put was this is the credential stored in Agent Vault. So the broker terminated TLS, it found this placeholder and it instead injected the real value and then it re-encrypted it on its way out, all on the broker's side of the wire. Now this echo bounces back what it received. And this is also why I used a throwaway value of this is the credential stored in Agent Vault instead of a real key. Now note, a normal API is not going to send the header token back to you. It's just going to authenticate and answer. The only thing that ever lived in Claude was this demo token. The broker is the only thing that changed this time around. Now everything routing through one broker is our control plane. And this is where a production setup looks a little bit different from the local demo. Locally, Agent Vault and Claude Code sit on the same machine. But if you're running multiple long-lived agents for a team, multi-box is going to be a better setup. Agent Vault on one box and the agent somewhere else, like another server, a worker, a web service. The broker becomes the boundary that all of our agents have to cross in order to reach external services. Now, regarding access, agents can't grant themselves access to anything. An agent can't add a service or a credential. But for agents that were running hands-off, like Hermes or OpenClaw, agents can request access to things. And so our agent opens up a proposal, which is basically like a pull request for access. A human approves it and puts in the actual token in here, and then this change is atomic and logged. Now zoom out to a real company. Maybe you have different agents in your company helping automate things. RevOps, marketing, solutions engineering, all doing useful things across different systems. As those agents sprawl, you don't want access decisions living in 4 different places on 4 different machines. You want one place to say what each agent can call, which credential it can use, and when that access should disappear. Now, this separation also helps with the isolation problem. In this multi-box scenario, the credential broker isn't sitting on the same runtime as the agents. The agent can make requests, but the secret material stays on the Agent Vault side of the boundary. And for local agents, we're still figuring out the cleanest sandbox story, but the credential brokering pattern still solves the immediate local problem. You can give these agents access to services and tools without actually handing them the keys. Now say I want to cut off an agent entirely. I can revoke its token, and in that instant, it is gone. And all of this, every brokered call, injection, every proposal lands in our Vault's audit logs. As we scroll through it, each row is one brokered request. The service it went to, which credential was injected, the agent that made the call if there's one associated with it, and a timestamp. If you read straight down the audit log, you can see exactly what each agent did and which key it used, except none of them ever actually held the key. So that is how Agent Vault works. The agent never holds the secret. Egress can be enforced, and access is proposed, approved, and audited. And none of this is tied to the agents that I showed you or to where you run it. Anything that speaks HTTP and respects a proxy works the same way. Whether that's Claude Code, Cursor, Codex, Hermes, a script you wrote on your device, something that you have in a CI pipeline. And if you want to see it set up end-to-end with a specific agent, we have videos out with Hermes and OpenClaw and Agent Vault. I'll link both of those in the description. Agent Vault is open source and it's quick to get started. I'll drop a link in the description for that as well. The point is simple. Your agents shouldn't see your secrets, and with a broker in the loop, they can't. Thanks for watching.